In the previous sections, we studied double integrals.
You didn't share yet, right?
Did I didn't know. Do you see the screen or not yet? Okay.
No,
Maybe I did. No, I did not share then. Okay, just send me. Yeah, okay. Yeah, okay. Now you can see the screen, right? Okay.
Yes.
Yes. Okay. So in the previous sections, we dealt with double integrals, where we consider functions of two variables. Now we do triple integrals, and we deal with functions of three variables. Okay. Okay. Now briefly, just to make you happy, in fact. Okay. Briefly, really, triple integrals will be a generalization of double integrals. Okay. The main ideas are given in double integrals. Once you understand them here, there is just one-step generalization, generalizations. Okay. So really, if you are comfortable with double integral, you will be comfortable also with the triple integrals. Okay. So this is actually briefly what it is. So just pay attention to what I will do here, and always ask yourself, yes, just to ask, is it a generalization of double integrals or not? Okay. You will see really most of the times, almost 90% of the times, if not more, they are generalizations of double integrals. Okay. For now, we have a function of three variables of x, y, z, continuous on a closed and bounded, solid region, D in a 3D space, and 3D space. Okay. So you have a function of three variables and a solid D in a 3D space. So you have something like this. This is x, and this is y, and this is z. And you have a solid. Okay, a solid. Okay. A solid, like, for example, a cylinder, a disc, a cylinder, let me see, a box, filled, كل حاجة solid معناته it is a filled object, as a filled solid, the points inside are included. Okay. Now here, in the double integral, we started with the volume problem. Here we cannot start with the volume problem because we cannot graph a function of three variables. You need four-dimensional space. So really, we cannot ask about the volume problem here. Okay. So how to define the triple integral here without a volume problem? Well, we do a generalization of what we did in double integral. How? Okay. Well, yes, in double integral, we started with a volume problem. But what is the procedure? You take the region, you divide it, you take a typical rectangle, a sample point, then evaluate the function at a sample point, i.e. you just form a Riemann sum, a double Riemann sum, and then you take limits. You find a Riemann sum, and then you take limits. Okay. Here we do this, we ignore the geometric meaning, but we do Riemann sum. We do Riemann sum. Okay. How to do the Riemann sum? This is the solid D. You take the solid D and divide it. Divide D in two boxes. This is H, that situation again. I will take it again. So this is H. This is X, and this is Y, and this is Z. And this is H, the box here. That's solid. You divide it by taking vertical lines, okay, parallel to the Z-axis. And horizontal line parallel to the y-axis, and lines parallel to the x-axis. Okay. You divide the solid by lines parallel to x-axis, y-axis, and z-axis. This will divide the the solid into small boxes. You take a typical box, okay? So this is a typical box. So this is delta x, this is delta y, and this is delta z. You take a star point, so this is h, the point, typical point, this is h, star point, x star, y star, z star, okay. I, j, k, I, j, k, I, j, k, okay. But here I have to take 3 subscripts, I, j, k. I for the lines parallel to the x-axis, j for the lines parallel to the y-axis, k for the lines parallel to the z-axis, okay. But this is h, the star point, okay. This is a box. What is the volume of the box? Delta v. What is delta v? It is delta x times delta y times delta z, or any other order, معناتها حيكون delta x, delta z, delta y, delta z, delta x, any other order, okay. And this is delta v for the box, okay. It is a box. I think we talk about the delta v. Now, how to form the Riemann sum? You evaluate the function at the star point of a star. So this is of a star, ijk, y star, ijk, z star, ijk, times the volume of the base, delta v, okay. This is our base, delta v, okay. So you take a box, a star point, evaluate the function at the star point times the volume here, delta v. You do the same thing for all boxes in this solid. You take that. Then in this case, you take 3 sums. One for I, one for j, one for k, m, n, let me say t. Okay. This is a triple Riemann sum. Okay. Then you take a limit, okay, limit as m, n, t goes to infinity. Okay. And this is a limit of a Riemann sum. Well, you change it to the notation of the integration. Okay. 3 limits of 3 sums حيكون triple integral. The function of x, y, z. Delta v becomes dv over d. Okay. What is dv? حتكون you change delta to d حتكون dx, dy, dz, or any other order, in any other order. Okay. The definition now of the triple integral, it is a limit of a triple Riemann sum. A limit of a triple Riemann sum. Okay. And you do the procedure that we did in double integrals, but without worrying about the geometric meaning. Okay. It is a limit of a triple Riemann sum. A limit of a Riemann sum. So this is the definition of the triple integral. A limit of a triple Riemann sum. Okay. So this is the definition. Okay. If this is clear up to now, okay, just write one in the chat. Write one in the chat. So we worry only about really just without worrying about the geometric meaning. It is a definition. Limit of a Riemann sum. فقط. Okay. In that case, really the procedure is just similar to the procedure in double integrals. But there we have geometric meaning. Here, there is no need for a geometric meaning. Okay. This is number 1. Okay. 2.
الدي كابيتال دي معناتها نفس معنى الار في الدبل انتجرات.
No, ما لها. D هذا solid domain, and your function here, the domain will be a solid in 3 space. So it is a solid.
قصدي في الترابل انتجرات تحت. كابيتال دي.
هذا هي نفسها هذا دي ولا في different؟ هي نفسها دي. يعني you are taking triple integral of the function over the domain D, the solid D.
دكتور؟
نعم.
هل عادي إذا مثلا بدينا بدي إكس دي زد يعني زي
فهنا you wait for a while. Let's go step by step. We'll come to the sequence. Okay. Wait for a while. Okay. فإنه إيش just إنه follow إيش follow me يعني in the beginning as I said in the beginning إنه notice إنه I claim إنه كله generalizations of double integral. So follow me step by step. Okay. To see whether really it is a generalization or not. Because if you feel it is really a generalization, then you will feel comfortable. You know, really, the ideas are repeated. Okay, the ideas will be repeated. So this will make you, as a student, and it makes you feel more comfortable. Yeah, you will not worry much about the type of questions you will consider later on. Okay, but this is the first one. Okay, now second thing here. Now. Okay. Now I will consider the following. This is important. Triple integral over d of 1 d dv. Okay. Okay. What do you think this equals what? Okay. Now if I take the function to be 1, now what is the triple integral of 1 over d dv? Okay.
The volume.
Okay, let's just recall something هنا. Previously we considered double integral over a region of 1 dA. What is this equals to?
Area.
dA معناته A area for R, area of R. This is area of R. Single integral from A to B 1 dx. This equals what? Okay. The length of the interval AB. 1 dimension, 2 dimensions, okay. X dx for the length, okay. Now here if it is triple integral of 1 dv over d حتكون ايش؟ volume of d, volume of d, and area of R, and length of the interval, But this becomes volume of d, volume of d. Volume of d. Okay. This is a generalization. Okay. Length, area, v, volume of d, volume of the solid d. Okay. 3. Okay. Now we have also in double, if a function of one variable, what is the average value? هيكون 1 over b minus a to b of x dx. For a function of 2 variable, what is the average value over a region? For a function of 2 variables. 1 over area of R. Double integral over R of x, y, d, dA. This is for average value for a function of 2 variable, for a function of 1 variable. Now what is the average value for a function of 3 variables? هتكون ايش؟ okay. 1 over the volume of d, volume of d. Triple integral over d of x, y, z, d, dv, d, dv. Again, generalization. Just generalization. You go one step more, okay. Okay. In the first case, you have definition. These are really the applications. Now, these will keep this later on, okay. We'll illustrate these later on, maybe not today, they will be illustrated next time. So just leave them for a while. But at least by now, up to now, really, just generalizations of double integrals. كله ايش generalizations of double integrals, okay. How we will use 2 specifically, you wait for next time. So leave it for a while, okay. Now this is ايش the definition. Now the next step is to evaluate a triple integral. So to evaluate it, I need to set up the limits of integration. To set up the limits of integration, it depends on d. So what are the for the solid d, okay. فهنا الآن the next step, setting up the limits of integration, setting up the limits of integration. Okay. And it will have different types of d. The first case, d, a rectangular box, a rectangular box. Okay, and this is H D. Okay, let me sketch a rectangular box here. It will be something like this. Okay. So this is a rectangular box in space and in space. Okay. Well, how to describe a rectangular box? It is the following. You take the x interval AB, the y interval CD, the z interval HK. This is the x interval, this is the y interval, this is the z interval H2K. This is a rectangular box, In double integrals, we have rectangular region, x interval and y interval only. Here you have a solid, a rectangular box. So you have to consider also the z interval, HK. Okay. A generalization from a rectangular to a rectangular box. Okay. Now in this case, how to set up the limits of integration? Triple integral over d of f dv. Okay, this is triple integral of x, y, and z. So we need to know what is dv here. What is dv? As above, طبعا dv was given as a dx, dy, dz, or any other order. If d is a rectangular box, which order do you choose? Okay. What do you think? Okay. If d is a rectangular box, what is dv that we can choose here?
dx dy.
Again, what is the order that we choose for dv here?
Any order.
Any order. You are free to choose. Okay. If I can choose dx, dy, dz. In this case, the inner will go with the inner differential, middle integral will go with the middle differential, outer will go with the outer. So what is the limits of the inner? They go with the x. What is the x values? A to B. The middle integral, the limits of the middle will go with the dy. So I take the y values of the solid, the y value C to D. Okay. The outer will go with dz. And the z values are H2K. Okay. Or I can choose the following. Okay. Of x, y, z, dx. Switch between the other two. Instead of dy, dz, I can take dz, dy. Then the inner x, A to B. The middle with respect to z, H2K. The outer with respect to y, C to D. Okay. Or I can start with dy, and I started with dx, then dy dz, or dz dy. If you start with dy, then you have dx dz, or dz dx. Okay. Or you start with dz, then either dx dy, or dy dx. Okay. So you have 6 possibilities. If D is a rectangular box, the order is not important. You can choose any order you want. Okay. You can choose any order you want. Okay. You have 6 possibilities. Okay. So is it a generalization of the case of rectangular regions in double integrals or not? Okay.
Yes.
Is it or not? Yes. Okay. So this is the first case. Okay. Since it is now, let me just make sure. If it is clear, just write. Let me say, just write 2 in the chat if it is clear. Okay. If you feel it is really true, it is a generalization, so which is good. Okay.
Okay.
كيف؟
بس عندي سؤال بخصوص الآن احنا في الدروس الماضية
I voice يعني
صوتي واضح الآن؟
اوكي
في الدروس الماضية أخذنا أكثر من فوليوم.
يعني ايش اخذنا اكثر من فوليوم؟ اوكي،
يعني هذا الفوليوم هذا
هنا ما we did not talk about volume الآن. ما did not talk about any volume. هنا الآن هذا solid. I am integrating over a solid. Okay. And how to set up the limits of integration. We did not say anything about volumes. Okay.
لا فوق يا دكتور، قلت الأفرج والفوليوم.
اوكي، هنا يعني صح؟ 2
ما شفت الشاشة الآن. أيوة
2 صح ولا؟ أنا
أيوة.
you are asking talking about this one صح ولا؟
أيوة.
Yes, okay. And what did I say when after I write these two? I said these leave them for a while. Okay, leave them for a while. We'll discuss them next class. Okay.
إن شاء الله.
واضح. No, I have to go step by step. There is no rush. I wrote them and I write stars. I have to come to them. صح ولا لا? But I have to go step by step. يعني just to see how we build up our H rules, our H setting up the limits of integration. Once we know how to set up the limits of integration, the rest will be very simple with the example that I will give. Just leave them for a while. And I will talk about them. In fact, not today, of course, there is no time, but next class. I leave these. I put a star, so I will come to them definitely. We need to set up the limits of integration. Okay, and just follow me and remember the generalization. I claim in كل generalization. So up to now, yes, things are really generalization. Okay. But this is when D is a rectangular box. Okay, it is clear. Now we go to general solid, general H solids. D general solid, D a general solid, a general solid. Okay, general solid. Okay. So here for the D we have different times. Solids of type 1, solids of type 1. Solids of type 1, okay. Before I mention what is a solid of type 1, make a guess. What do you think? How many types of solids we will have here? Make a guess.
3.
How many types of solids discuss here? What is again?
3.
3. Exactly 3. Okay. Type 1, type 2, type 2. For functions of 3 variables. For regions, double integrals, we have 2. Type 1 and type 2. But here we have a 3. هناك functions of 2 variables, double integrals, and functions of 3 variables, triple integral, have a 3. Okay. So we start with solids of type 1. Concentrate on the solids of type 1. If you understand it, really type 2 and type 3 are similar. Okay. So what is solids of type 1? It is the following. So let me just sketch it here. So this is okay. So you have a surface here. Z equals G2 XY and another surface Z equals G1 XY. Okay. So this is the solid D. This is the solid D. This is the solid D. Geometrically, it is a solid between a lower surface and an upper surface. Upper and lower. Always when you keep the geometric meaning in your mind, it becomes easy to remember. It is a solid between a lower and an upper surface. A lower surface and an upper surface. Okay. We need to describe D. We need to describe D. This is the set of all X, Y, Z in R3. The description هو نفسه حيكون the limits as we did in the double integral. So we need to describe D. Okay. For the description is that I start with describing Z first. Okay. Okay, so let me just take another color here. So take arbitrary point. So this is an arbitrary point. Okay. X, Y, and Z. Okay. I need to describe Z, the Z value here. The Z value. Well, since I need Z and the possible values of Z, I take a line parallel to the Z-axis. You take a vertical line and you enter the solid. Okay. You enter the solid through this point and you leave it through this point. Okay. This is x, y, z. So what are the coordinates of this point here in the upper surface? X, y is the same because you are on the same line. So this is x, y. What about z on the upper surface? To find z, I substitute in G2. هتكون G2 xy. What are the y coordinates here? What are the coordinates of this point here? Again, xy is the same. And z, the z coordinate, you get it from G1. You substitute in G1. So this is G1 xy. xy. So you enter through Z1, through G1, the lower, you leave it through the outer. Z will go from on this line, from G1 to G2. From the Z coordinate of this lower point to the Z coordinate of the upper point on the upper surface. So these are the possible values of Z. Okay. So حتكون from G1 xy to G2 xy. From the lower surface to the upper surface, lower and upper. Okay. What about xy? Xy, we do the following. Okay. Okay. So I need here really the xy points of the solid. What are the xy points of the solid? To find the xy points of the solid, you take arbitrary point, which is, and take the projection. It will go to xy, xy. In fact, it is xy 0, because when you bring this point to the floor, z will be 0, xy 0. So we just leave the 0, or just put xy. Okay. So just do the same thing for other points. For every point, bring it down, projection, project it in the xy plane. If you do this, you will collect ايش, ايش, which is ايش a region. I put ايش a region. Okay. So this is ايش. Again, this is the region here. So this is R. Okay. You take the projection. You take the projection. The projection of the points in the xy plane. R. Projection. The projection of D into xy plane. To get the xy points. The xy points. So I need to describe the solid x, y, z. Z are okay. What about the xy point? You just bring them in the xy plane. So xy will be in R. Xy will be in R. Okay. Okay. The xy points of the solid, you bring them down. You will form a region. We call it a projection of D into the xy plane. Okay. So this is how we describe it. Okay. Now, when you make the description here, how to set up the limits of integration. So double integral of RD of f dv. If it is if D is a solid of type 1, a solid between lower surface and upper surface, Z and Z, you have to integrate first with respect to Z. Okay. So the inner of x, y, z, I have to integrate with respect to Z. Okay. If it is between lower and upper, Z to Z, I have to integrate first with respect to Z, dz. What are the limits of Z? G1 to G2, the lower surface to the upper surface. G1, xy to G2, xy. Okay. I am done with the one of the inner integral. What remains? Two integrals. So I leave the two integrals here. Okay. These are double integrals. So I write over the region R and I wrote H D dA. Okay. Once I am done from the inner, this is over. Okay. So I'm left with double integral. So just integrate them over R, over the projection, D, dA. Okay. So after this one, I have a double integral. How to set up the limits of a double integral? Well, you do whatever you did in the previous section, double integral. You look at R, is it type 1, type 2, or rectangular? And accordingly, you set up the limits of integration. Okay. So this is H. How to do the integral. If it is a solid of type 1, between two surfaces, you have to start between a lower and upper surface. You have to integrate first with respect to z. Okay, from the lower to the upper, lower to upper. You find the projection, the xy values of the solid, then you do a double integral. But this is type 1. Okay. Let me illustrate it with one example. Okay. Before the example, it seems in this explanation here, what is easy in lower surface and upper surface, they are fine. Usually from the sketch, from the graph, it is not difficult to find what is the lower surface and what is the upper surface. Okay. But from this explanation, what seems to be easy or not clear, you know how to find R, the projection. Okay. It seems not easy. But in fact, when we go to the examples, you will see how we find R, and it is really not difficult. Okay. But since you are making general description, general explanation, this is how we will write it. Okay. But when you go to the examples, you will see really the R. You will see really it is not difficult to find R. Okay. Okay. So let me now give you one example just to see how this will be done. Okay. Example. Evaluate. And as I said last week, always in each section, you will have two types of problems: evaluation and applications. Now do evaluation. Evaluate triple integral over D of Z dV. Okay, where D is the solid bounded by the planes x equal to 0, y equal to 0, z equal to 0, x plus y plus z equals 1. Okay. And you need to set up the limits of integration. Then you have to sketch D, the solid D, and you have these basic graphs. You have to know them. Okay, first sketch D first. So this is the sketch. Okay. Let's review, a reminder, just in case you forget. Just pay attention. Z equal to 0. What is the graph of Z equal to 0?
XY plane.
XY plane, the floor. What about y equal to 0?
XZ plane.
XZ plane, this wall. And x equal to 0 will be the YZ plane. And these are the floor and the two walls. Okay. And these are done. What about x plus y plus z equals 1? It is a plane. How to sketch a plane? If you remember in chapter 12, you need the 3 points, and the simplest 3 points are the intercepts. What is the x-intercept? You set y and z equal to 0, you get x equals 1. So this is x equals 1. The y-intercept, you set x and z 0, you get y equals 1. So this is y equals 1. Z-intercept, you set x and y to be 0, you get z equals 1. So this is z equals 1. Okay. Then you join the 3 intercepts. You get a triangular plane. طبعا it will be extended, but we usually just joining the 3 points, and in our mind we extend the plane all over the space. Okay, so this is x plus y plus z equals 1. Okay, what is our solid? The solid is bounded by these 4 planes, and between this triangular plane, the floor and the two walls. Okay. So what is the solid? What is the solid? Okay. The solid will be the following. Okay. Everything below the triangle and in the corner, in the corner. Okay. In the wall and below the plane. Okay. In the corner. Okay. So this is the solid. Okay. Everything below the triangle plane and inside in the corner. In this corner. Okay. So this is our solid. We need to describe the solid. Let me go here. So pay attention. D. I need to know what is the lower surface and the upper surface. Lower and upper. Okay. Again, so pay attention. This shouldn't be difficult from the graph. Okay. You don't need to be a genius to know what is the lower surface and what is the upper surface. So in our case here, what is the upper surface here? Or just to make it even clearer, assume you are here somewhere in this point here, a point inside. You are sitting here inside. What is the surface above your head? If you are sitting near the corner here, what is the surface above your head? Okay. If you are sitting here, for example, what is the surface above your head?
Z is equal to.
Give me the name of the surface. If you are here, what is the surface above your head? If you are sitting here, okay.
Triangle.
The triangular plane, the triangle. So this is the upper surface. So I write it as z equals 1 minus x minus y. لازم يكون z is a function of x and y, okay. فz between the upper حتكون 1 minus x minus y. The triangular plane is the upper surface. If you are sitting here, what is above your head is the triangular plane, okay. Now if you are sitting here, you are sitting on what, okay? What is under you? You are sitting over what, okay? What is the lower surface? Or you are sitting over what?
Plane.
The XY plane. You are sitting in the floor. What is the equation of the floor, okay? Z equals to 0. فحتكون from 0 to 1 minus x minus y. So the lower is the floor, z equal to 0. The upper is the triangular plane, 1 minus x minus y. If this is not clear, okay, there is another way to find it, okay. Well, I need the limits of z, so I have to move in the direction of the z-axis, okay. You enter هنا. I enter here, and then I leave here, okay. I leave here. So this is ايش? Just I enter here, and then you go, and then up, okay. So I leave here, okay. If you take a vertical line and through the solid in the direction of the z-axis, you enter through the floor. I enter the solid through the floor. So this is n. z equal to 0. And I leave it through the triangular region, which is z1 minus x minus 1. This is the upper. This is out. Okay. If you take a line, you enter the solid through the floor, and you leave it through the triangular region. So this is the lower, and this is the upper. Okay. So this is for z. Now I need xy. xy. It is in R. So what is R? بمعنى آخر, what is the xy? What is the xy region of my solid? What is the xy region of my solids? Okay. What are the possible xy values? xy values هنا. The R region. The xy R will be the xy region. What is the xy region of my solid here? What is the xy region? Okay. Can you see it from? What is the xy region of my solid here? Okay. What is it? Okay.
The triangle.
Where? Which triangle?
On the XY plane.
In the XY plane. In the R. Okay. يعني حتكون هذه بالبلاك. This is the black region here. Okay. This region, the black. Okay. Any point here, the projection will be in this triangle. Any point here, XY will be in this triangle, the black triangle. Okay. This is R. The XY region of my solid. Okay. So I bring it out here. This is R, and this is H. This is X, and this is Y. Along the X-axis, I take X equals 1, and along the Y-axis, I have Y equals 1, and this is the line. And this is the region. This is H, the region. Okay. This is my region R. Okay. This is H R. Okay. I will leave it for a while. I will come back to it. So now I will set up the limits of integration. This is H my triple integral. So this is H now. Triple integral over d z dv equal. Pay attention and don't ask me why I put z here. I did not put it. It is in the question. It is already in the question. So evaluate Z, triple integral of Z dV. Okay, so Z is the function of x, y, z equals Z. So it is given in the code. It is evaluation. Evaluate this function over triple integral of this over d. Okay, so it is there. Now I have to start. It is a type 1. I have to start integrating with respect to Z. Okay, so the inner integral of Z dz. I have to integrate with respect to Z. What are the limits of Z? 0 to 1 minus x minus 1. 0 to 1 minus x minus y. Okay. This is for the inner. Then I just, what remains is the outer two. The other two are double integrals over r dA. But we leave them for a while. Okay. But I have to integrate with respect to Z. It is a solid between lower and upper. Lower surface, upper surface. You integrate with respect to Z. Now evaluate this integral here. Of course, هتكون ايش? half z square from z equal to 0 to z equals 1 minus x minus 1. So this is half 1 minus x minus y squared minus 0. Minus 0. So this is the value of the inner integral. So I will write it down. 1 minus x minus y squared. Now double integral over r dA dd. Okay. After you finish evaluating the inner, this is the value. I end up with what? A double integral. So I am now here. I am in section H 15.2 and 0.1. Okay. 15.2 and 0.1. In the previous section. So how to set up this? Well, I need to know what is R. This is my R, okay. Is it type 1 or type 2 or whatever? So you have to know what we did in the previous sections, okay. فهنا الآن I will start to just outer. I will take X interval. So what is X between what and what? The X interval 0 to 1, 0 to 1. Inner, lower and upper curve. So this is X here. This is inner, lower curve, and this is out. So here you are entering the region through H, through what? Okay. The x-axis. What is the equation of the x-axis?
Y is equal
to 0. So this is H, the inner. Okay. And here the lower. What is the upper? This line. What is the equation of this line? If you have the 2 points, 1, 0 and 0, 1, you can find the equation of the line. This is x plus y equals 1 minus x. Okay. 0 to 1 minus. It is a line. You can find the equation of the line easily. Okay. So the lower curve, the upper curve. But these are the limits of y. Okay. So now I write the following here. Half 1 minus x minus y squared. dy dx. The outer x 0 to 1. The inner y 0 to 1 minus x. And then you just say that the rest of the evaluation is given in the note. So I will leave it for you to read from the note. Okay. Yeah, you notice here an important point here, which is after you integrate the inner, you will end up with a double integral. And to set up the double of integrals, I have to use the previous section. بمعنى آخر, if in every problem of triple integral or every problem in triple integral will include double integral, will include everything you did previously. Okay. So the double integral is included here. You have no choice. Okay. You have no choice. Okay. So this is one example about evaluation. We give more example next time. Okay. حد عنده سؤال؟
It's not difficult, but it's
yeah, well, I mean, this is life, and it is not always, things are not always short. The main idea is clear. Once we know the main idea, أحيانا calculation is long. You have to do your best just to make a practice and to try to work quicker or faster. Okay. I will give more examples, and I will go to the application next time, inshallah. Okay. But you keep in your mind before you leave, you keep in your mind, really the ideas are really generalizations of what we do with the double integrals. And with the last example, you notice now in every problem in triple integral, we will use double integral. We will use what we did previously last week. We'll review them again, okay? We'll apply them again, okay? Okay, so this is Ash, this is Ash, this is, I will give more example next time, okay? Now I gave you, I made an announcement for quiz number 5, and I mentioned that it will be on Thursday, but I wrote a note also in case you need to postpone the quiz, okay? But now, did you decide anything or not? You want to leave it on Thursday or you want to postpone it?
Can you postpone it to Sunday, Doctor?
Postpone.
Yes, Doctor.
It's better to take it on Sunday, Doctor.
Okay, so now if just let me see now if can you just raise your, if you want to postpone, just raise your hand. So let me see how many. Okay. طبعا if you want my advice, طبعا what do you want my advice also or not? Okay.
Why not, Doctor?
Yes, sure.
Well, my advice is to postpone to Sunday. The reason is the following. في النهاية يعني the 3 sections on the quiz about double integrals, and in this week we will review double integrals. As you notice in the last example, in every question in a triple integral, you will end up with a double integral. You need to set up the limits. So we will do review of double integrals. We will review what we did last week. So if you are in doubt of some point, now with more examples, it should be now easier, or with more examples. So every problem in a triple integral will contain a problem in double integral. So more examples, more review. And then, as I said in the beginning, if you remember, you will know how to set up the limits of integration by brute force. يعني you have no choice. غصب عليك لازم with the many problems or examples we give, it will be not difficult to really set up the limits of integration. So I suggest طبعا to be postponed. Okay. Okay. يلا hurry up. الآن هو you are 38 students, فالآن عندكم 24 يعني still 11 students. Okay. الغالبية يعني انتم. The majority wants to be postponed. Okay, 26, 27. Okay, 28. It's almost all يعني 30. خلاص بما انه الغالبيه الان هي 30، بما انه الغالبيه يبقى postpone ف we will postpone it. Okay. Okay. One last thing طبعا هنا, don't forget you have evaluation, so you shouldn't wait until I tell you to do the evaluation. And just 3 or 4 students do the evaluation. This is not acceptable. Okay. So please do the evaluation. Okay. Okay, if you have no question, you can leave. Have a nice day. If you have a question, you can ask.
Thank you, Doctor.
Doctor.
Bravo.